Hello, I'm Neil. In this video we're going to talk about what is cloud rapid elasticity, what it is and where it comes from, and how it benefits us. Let's get into it. What is cloud? What is rapid elasticity? In the last video, link in the description below, we talked about what is cloud and the NIST description for it. This video we're going to talk about rapid elasticity and how it is an important essential characteristic of cloud. If you like content like this, don't forget to like and subscribe to the video, and if you like reading, there's a book which this content is based on. Rapid elasticity. It doesn't get any easier to say, but here's what it is. The appearance of unlimited resources that can be elastically provisioned and released, in some cases automatically, to scale rapidly outward or inward to match demand. And this is an important part of cloud, and we're going to talk about this further. But first, a little history lesson so we know how we got here. In the beginning, a long time ago, there was mainframes. They were massive things that would take up whole buildings, and they are often used either by institutes performing research or finance departments. One big machine and lots of dumb terminals hanging off it, a dumb terminal being a screen and a keyboard. No mice yet. These things would take years to build, months to install, and weeks to get training on. However, late 70s, early 80s, home computers started to happen. First in the form of kits, and then commodity hardware that you could actually go out and buy for a couple of £100, like the ZX Spectrum, or the Acorn Electron, or the Commodore 64, or VIC-20 before that. So these brought computers into people's homes, and got people more interested, developing what you could use a computer for, which then led on to, in the 90s, a widespread use of the PC compatible and the release of a program called Windows. Before that, everything was largely keyboard based, unless you were fortunate enough to have something really whizzy like a Silicon Graphics workstation. With a computer on everyone's desk, computers started to leave the finance departments and were being used in other areas of the business. Having Windows as an interface made a lot of things very easy and simplified the training aspects of using a computer. You can just clicky instead. With Windows computers appearing on the desks in other departments outside of finance, people found other uses for the computers within a business, like writing letters, helping customers with their billing inquiries, and other things like that. You still had a lead time of when you buy a computer though. Can you remember the last time you bought a laptop? You got it in the shop, you took it home, you plugged it in, you switch it on, and the first thing it says is, set me up. What's your name usually, so it can set you up a user account. And then it sits there for a couple of moments whilst it does stuff. Who knows what it's doing? Icon endlessly looping around while it does things to your machine to get ready, whatever that is. So that's setting up, installing the software, customizing it to your username, and other bits and bobs it needs to do to make it usable, as opposed to the factory configuration where it doesn't have any of that stuff installed. It takes time, right? With Windows PCs on every desk, we then started to get in the realms of having to share information. I've written this letter, but I want to store it somewhere so that somebody else can use it. Or more importantly, the HR department can use the same template as the sales department. And so we've got that corporate image, all running off of the same templates in a group directory so that everyone can have that corporate image. This meant we needed servers. Windows servers were also kept in little dark cupboards, safe from anyone touching them so that the data could be backed up, and obviously keeping the data safe is very important. Our next innovation is when those servers started to get smaller. So to start with, there were 4 U's, maybe freestanding, maybe in a rack. They then reduced down to 3 U's, and 2 U's, and 1 U, which many people might call a pizza box, about how big it is in terms of height. And then where to go from 1 U? Well, we can make stuff even smaller. A blade is simply a smaller server because of all the electronics being reduced in size. Take your IBM mainframe down to your mobile phone. Your mobile phone's got more power than the earliest mainframes have. So the servers have been reduced inside to a blade, and so now where you had 3 U that could take up the space, 1 server, we can now slot 8 blades into that same space. With the commodity hardware getting smaller and smaller, that means there's more of it and it gets cheaper, which leads on to our next innovation, which is virtual infrastructure. We've still got the physical hardware, the blades, but now we can configure them to be a virtual server or virtual network equipment. Don't get me wrong, blades still takes physical install time and a lead time when you order it from the factory. But once we've got them installed, we can then create virtual machines and destroy virtual machines very quickly. And this is where we get onto the rapid elasticity. So how do we control the elasticity? Well, often cloud providers will provide you with an API, an application programmable interface. This means that machines can talk to each other, which is useful. If you've got a batch script or something that needs to do something, it could invoke a new server, probably using the API directly, or maybe through a useful tool like Terraform. Once that server's running, which can take a matter of minutes, is running your image that you've designed. You might have a blank operating system, and then use a configuration management tool like Puppet or Chef or Ansible in order to give it personality. So the server can be up and running very rapidly. Very useful if we've just started to pay for it. We want to get use out of it as soon as we can. It builds, does its thing. We can call the API to destroy it again once we've finished. Ask for server, get it built, make it available, utilize it, destroy it after. The hardware's still there, and this is where the cloud provider comes in. They use cheap commodity hardware. In fact, Amazon tend to install servers at a rate of a rack or 2 a day in their data center. That's a whole rack configured with physical hardware to their specification, including switches, that once installed and powered up and connected to the network is ready to perform workloads, so that when you call that API, it will be allocated something somewhere on that hardware rack and spring a new virtual machine into life. The lead times from ordering it, manufacturing it, and installing it have all been taken away by the cloud provider. All you need to do is one API call to their interface, either yourself through a console or automatically through a batch process, and you get a new server within 5 minutes. And how do we achieve this? Well, DevOps came along. DevOps is the way of automating all of the infrastructure side of what we have in the data center. So the physical guys go in there and they've given us a new rack. Or we don't even run a data center anymore. We're using a cloud provider. We can't see the physical hardware. It's miles away from us. We don't need to touch it. We have an API in between us and it so that we can control it. And the DevOps guys, they're creating scripts and infrastructure as code so that we can create this virtual infrastructure. And more importantly, grow it. If we want to scale from 1 to 10, we can do that very quickly. If we want to scale back from 10 down to 1 because the demand has gone away, then we can do that too. I hope you found that useful, and in the next video we'll be talking about what is cloud, measured service. See you then.